This video covers sections probability E2 and E3. To begin, let's look at the multiplication law of probability. Now, the multiplication law of probability states that for independent events, the probability of one event and another event occurring together is equal to the product of the probabilities of each individual event. Now, the thing to remember here is we are talking about independent events. So events that don't affect the other one. So this rule is often called the AND rule. For independent events, the probability of A and B occurring is equal to the probability of event A multiplied by the probability of event B. So you can see that here. So that AND means that they both have to occur. And again, remembering we are talking about independent events. So events that don't affect each other. So the probability of one occurring has no effect on the probability of the other occurring. Now, using the multiplication law of probability saves us having to draw up a sample space. So let's look at some examples. Determine the probability of each of the following events. A two-child family contains 2 girls. Now, if I used a sample space, I'd have to go child 1, child 2, boy, girl, boy, girl, boy, boy, and I'm even taking a shortcut here by abbreviating. So I'd have my sample space. So the probability of 2 girls would be 1 in 4. Using the multiplication law, the probability of girl, girl is going to be the probability of girl multiplied by the probability of girl. And we are assuming that it's 1 in 2. There's equal chance of having boy and a girl, which technically isn't true. But anyway, 1 times 1 is 1, 2 times 2 is 4. So it is much easier to do that multiplication law. This was a simple sample space. Can you imagine the more complicated ones? So here, getting a head and an even number when rolling a die and tossing a coin. Again, you would have to go coin and die. In your coin, you can have a head and a tail. Your die, you can have 1, 2, 3, 4, 5, 6. So it's head 1, head 2, head 3, head 4, head 5, head 6. Tail 1, tail 2, tail 3, tail 4, tail 5, tail 6. So you can see my sample space. So the probability of getting a head and an even number would be 1, 2, 3. Out of 2, 4, 6, 8, 10, 12, which would be 1 in 4. Looking at the opposite, the multiplication law to do it, so the probability of getting a head and even is going to be the probability of a head times by the probability of even. Now, the probability of getting a head when you're tossing a coin is 1 in 2. Probability of getting even number is 3 out of 6. So 1 times 3 is 3, 2 times 6 is 12, and that reduces to 1 over 4. Okay, much quicker to do the multiplication law. Next, when selecting an entree, main, meal and dessert combination from the following menu. So this one's much more complicated. Now you want to order chicken and ice cream. So the probability of chicken and ice cream. Now you can remember how detailed the sample space for this one was. So it's just going to be the probability of chicken times by the probability of ice cream. Well, the probability of selecting chicken, you've got 1 out of 3 different mains, so 1 in 3. Probability of ice cream is 1 in 2, so 1 over 6. Much quicker than the sample space. Now let's look at the addition law of probability. The addition law of probability states for mutually exclusive events, the probability of either one event or the other event occurring is equal to the sum of probabilities of each individual event. So this is often called the OR rule. It's event A or event B. So notice when we were doing the multiplication rule, both things had to occur. Here it's one or the other. And we express that like this. So the probability of A or B equals the probability of A plus the probability of B. Again, it saves a lot of time than having to draw up a sample space. So let's look at an example. Determine the probability of each of the following events. Choosing a red ball or a blue ball from a bag containing 3 red balls, 4 blue balls and 5 green balls. So note, it's one or the other. Okay, so we're looking at probability of red or blue. So that's going to be the probability of red plus the probability of blue. So the probability of red, we've got 3 red balls. How many have we got in total? 3 plus 4 is 7. 7 plus 5 is 12. The probability of blue is 4 over 12. So 3 plus 4 is 7 over 12. Much quicker. Next, for a 2-child family having 1 boy and 1 girl. Now note that there's an and there. So the probability of a boy and a girl is going to be equal to the probability of boy-girl plus the probability of girl-boy. Okay, another way of looking at that is it's a probability of a boy then a girl or the probability of girl then a boy. So you can see these or happening there. So I can go the probability of boy-girl plus the probability of girl-boy. Now what we can do is do the multiplication law within the addition law. So this becomes a probability of B times the probability of G plus the probability of G times by the probability of B. Sorry about getting really squished. So 1 over 2 times 1 over 2 plus 1 over 2 times 1 over 2. So a quarter plus a quarter, which is 2 over 4 or 1/2. One for you to do, so pause the video and have a go. Determine the probability of rolling an even score on a die. Okay, so have a go yourself. So you might just realise how many evens you've got, or you can just think probability of even is going to be the probability of a 2 or a 4 or a 6. So the probability of 2 plus the probability of 4 plus the probability of 6. I probably wouldn't bother doing it this way, but so 1 in 6 plus 1 in 6 plus 1 in 6, which is 3 over 6, which is 1/2. You could have just realised, well, half the numbers are even. So what now? Complete exercises in the textbook, probability E2 and probability E3.